All right, for problem number 14, we're going to have 100 grams of ice at 0 degrees Celsius, and we're going to heat it to steam at 100 degrees Celsius. Now, the key portions, make sure you understand this, is that we have ice and we want to go to steam. We're not taking liquid at 0 degrees and then raising it to 100 degrees. We have ice first. So first we have to take ice and melt it to water. And then we're going to raise the temperature of the water to, let me just write it, ice. And then once we have the water, we're going to raise the temperature of the water to 100 degrees, and then we're going to boil away the water into steam. Now, if you've been following along, you can see that here's your temperature scale, temperature over here, and energy's here. This is all covered in the previous slide. Hopefully you were paying attention. Hopefully you looked at it. But the flat area, we're going to use our M delta H because there's no temperature change. We're just simply melting ice. Once we melt the ice and it's water, we can then raise the temperature of water using MCAT. And then once we raise the temperature of water to 100 degrees, then we have to boil away the water and we have to turn it into steam. We're going to go again to M delta H. So let's clear all that out. Let's see what we have. So step one, here's all the stuff we need. I think that stuff. Okay, so step one, we're going to do M delta H. Again, we're going to convert ice to water. Once we convert ice to water, then we can raise the temperature. But first, we got to convert ice to water. So we're going to have our mass, which is 180 grams, and our delta H of fusion, which is converting ice to water. That is 334 joules per gram. The next step, step two, now we have our water. We're going to raise the temperature of water from 0 to 100. We're going to be using MCAT, MC delta T. And we got our water, and we're going to go from 0 to 100. The mass is still the same, so mass is 180 grams. CP of water is 4.184, and delta T is 100. We're going from 0 to 100. Our final is 100. Our initial is 0, so 100 minus 0 is 100. Actually, I forgot to go and cross these out. Make sure everything cancels out so that you have everything in the right place. So you're always left with joules. We have joules here. We have joules there. And the step three, again, is taking water at 100 degrees Celsius and turn it into steam at 100 degrees Celsius. So no temperature change. That's what we're going to use. M delta H. Again, water to steam. Our mass is still 180 grams. Now the delta H of vaporization. We're going to be using this number 2260 or 2257. Pretty much the same thing, but 2260 for me right now. And make sure everything's lined up. You're left with joules. Whatever those are equal to. We're going to add them all up. And that's going to be our total energy. So 6,120 joules for the first one, 75,240 joules for the second one, and 406,260 joules for the third one. Make sure those numbers are all the same for you. Make sure you did all your calculations. And total would be 541,620 joules. If I were to get sig figs, I know how much you guys love sig figs. I guess that would be 5,400 and 5,401 600 541,600 joules. Number 15. Calculate the energy released as 5 moles of steam at 100 degrees Celsius is cooled to 0 degrees Celsius ice. So again, key points, steam and ice. We have steam. We're going the opposite way now. Let's draw our graph. temperature, energy. So now we're starting with steam. We have to cool down steam. Or sorry, we have to go from, so steam, we have to convert steam to water. And then once we have water, we cool down water into 0. And that is really bad. And then once we have the water cool down to 0, then we're going to convert that water into ice. And the flat areas will be M delta H. The slanted areas where the temperature changes is going to be our MC delta T. So step 1, we're turning steam into water. We're going to use here's our values. We're going to use, let's see, that's what we did first. First, we're going to take the 5 moles and just convert that to 90 grams of steam using the periodic table where it's 18 grams per moles for water. That way we can just plug it in. We don't have to keep doing it over and over again. So immediately we just converted moles to grams. Then we go ahead and take M delta H, and we're going to convert that steam into water. Now, again, we're going steam into water, which means it's getting colder. So we're going to use that. I don't know why it's not there. We're going to use a negative delta H. And while we're at it, we're going to have a negative fusion also. I don't know why I didn't put that there. Didn't have my plus or minus sign. So Q is equal to M delta H. Our mass is 90 grams. And we're going to use a negative 200. Oh, we're using 2257 now. I'm not lazy this slide. Anyway, so grams cancels out. You're left with joules. We're going to add that up later, whatever that equals to. We're going to add them all up together. Step 2, once we have converted steam to water, now we're going to take that water and cool it down from 100 degrees to 0 degrees. Since we're using temperature, we're going from 100 to 0, we need to use our MC delta T equation. And we're going from 100 degrees Celsius to 0 degrees Celsius for water. Still 90 grams. But now the final is 0. The initial is 100. So basically you're doing 0 minus 100. So we'll have a negative delta T. So 90 grams, 4.18. I didn't use 4.184 this time, so I'm being lazy here, but not on my 2257. Anyway, still the specific heat of water is 4.184 using negative delta T. So we'll come out to a negative, but just making sure everything cancels out. We're left with joules. We'll add that up later. Step 3, now that we have 0 degrees water, we're going to convert that water to ice. So we're going to use our M delta H. And our mass is still, going to go 0 degrees water, 0 degrees Celsius water to 0 degrees Celsius ice. And mass is still 90. Now our delta H of fusion is negative 333.55 joules per gram. Grams cancel out, left with joules. Add all those up. Negative 203,130 plus a negative 37,620 plus a negative 30,019.5 joules for a total of negative 270,769 joules. Sig figs be 5. Nope, I don't like 2 sig figs, but that'll be negative 270,000 joules. Bonus. We'll do the bonus. Actually, do you guys want to do? I'll skip that to another slide.